Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about carbon capture and storage. Generally, it's also called as carbon capture. So let's dive right into it. Now, first thing we have to understand what is carbon dioxide. So carbon dioxide is CO2, aka one carbon molecule of elemental level is bonded with two other elements. Elements I'm saying basically two atoms of oxygen element, and that creates this compound known as CO2. So basically, you have one oxygen, one carbon, one oxygen. So bonding is kind of like this. Now, the interesting part about this is it's colorless, so basically we cannot see it. It's odorless, so basically we cannot even smell it. And in ambient temperature and pressure, it's generally a gaseous. So on Earth, generally whenever you're talking about CO2, you're talking about it as a gas. Now, one thing you have to understand, which is very unique about it, this puppy absorbs and reflects infrared. Now, if you make a compound chain too big, let's say a hydrocarbon that is huge, like molecular chain, it will react with every single spectrum of electromagnetic radiation. However, once you start to make things smaller, let's say on an elemental level, each element will have a signature where it's like let's say X-ray goes through it, it's like I don't even care. Gamma rays goes through it, I don't even care. Basically infrared is like nope, that shall not pass. That's why we can make lasers that can like cut through steel but can be reflected. Like we use gold foil to basically reflect infrared lasers. Like think of it this way, we have a laser that can cut through 1 inch thick steel, and we are like just bounce it, landing, go there 90 degrees, then bend here, because each element has a unique property where there's like I'm gonna reflect this puppy. Now carbon dioxide, it's a compound, but it does have this unique ability to reflect basically infrared on a medium level. Basically infrared is a very long spectrum. Like if you talk about electromagnetic radiation, it's huge. Now you talk about basically visible spectrum, that's very tiny. Now in that spectrum, like it's almost 3 to 4 times longer than that in infrared. So sun, our primary power source, it gives out a lot of energy in almost every single spectrum. However, for us, majority part is comes through visible spectrum, so we are getting a lot of visible light and a lot of high energy infrared. Basically it is a very long range, so that's how we are receiving energy. Now whenever you receive energy and it interacts with your atom, the photons, when it dumps its energy into molecule, it shakes the molecule, gets back out. Now when it's doing that re-emitting part, basically it heats up and then it's like okay, now I'm at a high state, I need to cool down, it dumps a photon again. It generally the photon will go down in what we call energy state, so it will go from high energy infrared to mid-range energy infrared. Now that's the biggest problem. So that's what is happening. Basically sun is dumping YOLO amounts of energy into earth is like we got this, but we have to cool down. So when during night time, earth is like okay, all the energy absorption that has happened because of the sun side, we have to dump into the vacuum. Now if you are like dude, vacuum is a perfect insulator, you can dump in it using radiation. Now earth does have an atmosphere, but that atmosphere is almost transparent to basically mid infrared. Basically how we are re-emitting that system is just going through it, like atmosphere does not interact with it. However, carbon dioxide interacts with that specific spectrum. It's like I'm only gonna interact with that. That's the biggest problem. So what happens is like a photon of infrared that is taking energy away from earth goes there. Now in atmosphere generally it's supposed to just go through, maybe interact with one or two carbon dioxide molecule, nothing big happens. But if you increase the concentration, then what will happen, you will make a layer of carbon dioxide. It's just for illustration, you hit here. Now here's the deal, the photon is coming from the ground, it's hitting this layer or in atmosphere, basically this band. Now it's gonna re-emit again. Carbon dioxide cannot digest it, it has to re-emit it. Now re-emission, where would that happen? Again 50% chance it will happen in the vacuum direction, we're good, but 50% chance it also happens in the bad direction. Basically it comes back down to earth. And that's what's the problem with carbon dioxide. Basically the more carbon dioxide you put, the more likely it is that 50% happens downwards, because this is not a thin layer, it's separated. So even if let's say first molecule that hit it is like yeah, I don't want to bounce it back to earth, I'll bounce it to space, some other molecule will like nah, you shall go back. So the higher the concentration of CO2, the more guaranteed you get is like no, infrared is simply is not gonna escape to vacuum of space, it's simply gonna keep bouncing back, and every time it keep bouncing back, we end up dumping that energy into earth itself. So basically we are not changing how much energy is coming in, the input is not changing, it's just that rejection heat is no longer being rejected. Basically you are clogging up the drain pipe. That's the biggest problem with carbon dioxide, and how it's achieving that, that's the biggest problematic aspect. Whenever you are talking about compound, most compounds are not very stable. They're not like, I'm going to stay there for 10,000 years or even 1,000 years. Most compounds are not very long term stable. However, carbon dioxide, even though it's reacting with basically infrared, it's very stable, ironically. So it behaves like this. It's like when infrared hits it, it's like "Whee," and then it dumps it back, hits it, dumps it back, and it does not break. Like, it does break over thousands of years of time, but it does, it's technically for human lifespan is classified as stable system. So inherently we have to solve this puppy, or our exhaust system is simply not going to dump enough energy over time, and that's what cooked Venus. So that's the problem with our carbon dioxide solution problem. Now, where we are creating these things, where we are creating this problem, we are creating it in two core factors. Factor number one, high concentration, where these puppies are dumping YOLO amounts of carbon dioxide. Basically, you take humanity and you divide them in two categories. It's like 50% is coming from here and everybody else is 50%. That, major 50% would be these high concentration systems, which are generally the power plants and big industry. Power plant being specifically coal burning power plants, natural gas burning power plants, all these things, they are massive contributors. Basically, they alone make a very big chunk of carbon dioxide emissions. Then we come to big industry. For example, concrete, cement, they are like YOLO amounts of CO2 is produced in those systems. Then you are talking about steel energy, that's also dumping YOLO amounts of carbon dioxide. So all these things are what we call major producers of CO2. And then we have scattered sources. Basically, we are distributing carbon dioxide thoroughly everywhere. These are scattered sources. What are that? Transportation. Basically, we are transporting it everywhere. Every vehicle you ever seen generally is producing carbon dioxide. So that's how we are polluting it everywhere. We are like, distributing the system. And other thing, actually, practically speaking, everything we do is just releasing carbon dioxide. So it's wherever we live, there is a carbon dioxide source. You can be guaranteed about that. Now, some sources are concentrated, some sources are dilute, but that's the whole reality of it. Wherever we are, there is a carbon dioxide source. Heck, we ourselves also emit carbon dioxide. So tools, whenever we are talking about how the heck you're supposed to handle it, you have to handle it like, right tool for the right job kind of logic. So you can get it directly from the source. Like for example, a coal power plant is producing more than enough carbon dioxide. Like if you take, let's say, city has this coal power plant. This coal power plant will have equivalent signature of this whole city. It's like you can try to cover the whole city or just take care of this one spot. So many people are focusing on that front. Basically, high concentration benefit, high concentration side effect is location limited. Basically, you have to be next to a power plant. You cannot just build it anywhere. You have to be next to a power plant. And but it may sound super easy, but you have to understand power plants are what we call backbone industry. They have regulation on top of regulation with some extra regulation just for some fun sake, with some extra red tape. So that's a very serious limiting factor. Even if your technology works, it will take like 50, 30, 60 years to actually implement it. So that is a serious location limitation aspect of it. However, if you are doing something with carbon dioxide, these things are the best source simply because of the high concentration. Basically, if you are selling 5 kilograms of carbon dioxide, whatever rate, it's not that profitable. But if you are selling that same rate, but you are selling 5,000 tons of carbon dioxide, at that point it's like GG. So that's why a lot of people are focusing on that department, like specific tools. If you research any tools that are specifically made for carbon extraction, they will specify these are made for high concentration rate, because requirements are different. Trying to extract a lot of carbon dioxide is different compared to trying to extract like how our basically how plants extract oxygen. They are completely different thing. So you have high concentration system, then you have get it from ambient air. Basically, same way a plant gets carbon dioxide from the atmosphere, do the same thing. So basically, place it wherever you are comfortable with. Heck, think of it this way. There is this institute that is doing the research. Just put it on its rooftop. You don't have to go to a coal power plant. Just put it on its rooftop, and then you can refine the technology again and again, and then once you have final system, just put it wherever convenient. So it's like, hey dude, that location is the cheapest land and has the cheapest electricity. Just put it there. You're like, dude, that location that's super easy to reach, super accessible. Just put it there. That's the another benefit. However, low concentration. So if you are planning to do something with that carbon dioxide, if you are like, okay, I'm gonna make that into a product and sell it, you will not be in good luck because of that, because the concentration would be very low. It will work wherever, basically everywhere there is atmosphere, but it will not have high concentration. So right tool for the right job. Then we come to the CO2 aspect of it. It's like, what the hell are we gonna do with it? So we have to stop adding it. That's the first thing. It's like right now we are bleeding, and doctors have to be like, okay, let's cauterize the wound, let's make sure you stop bleeding. That's the step one. That like we have to stop adding it. Basically, we cannot keep adding more coal power plants or things of that nature. Thankfully, even though we are reacting slowly, we are reacting to it. And given the fact that economics are now in the favor of renewable technology, wind farms are producing power that is almost touching the coal power plant level. Solar already exceeded the coal power plant level. We are in a position where sooner or later every new power plant is created. That is like, okay, for every 5 coal power plants we are making 500 renewable power plants. It's like sooner or later we're gonna be take care of it. Like, we got this, but we have to do this. Like, this is absolute. We have to stop adding it. Then once we stop the bleeding, doctors have to be like, okay, let's solve the issues. We have to remove it. That's the unfortunate reality. It's like we cannot just like stop it and that train has left the station way too early. Like, if we started doing all these things, let's say as early as like 1950s, yes, that's how early we should have reacted to it. Then we may had a chance that Earth could have stabilized on, let's say, 300 parts per million, but train has left the station. So not only we have to stop adding it, we have to apply disc brake and we have to apply reverse gear. That's the problematic aspect. That's why people are focusing on carbon capture. Now, one short-term solution is make fuel out of carbon. Now, carbon dioxide has carbon. Carbon, if bonded with something else, becomes an awesome fuel. Heck, carbon bonded to itself is coal, and coal is GG fuel. Carbon bonded to hydrogen, that's jet fuel, that's GG fuel. So why not we do that? Now, again, you cannot do that from carbon dioxide directly because it's a byproduct. It has already dumped this molecular energy, chemical energy, pardon me, and it cannot do anything. So what if, let's say, you create a batch of algae biofuel? So what is algae doing? Algae is taking water, it's taking carbon dioxide from the atmosphere. It already has the evolutionary tools to do that. And how it's doing that is how the heck it has the energy to do that. Sun is like, bro, I got you back. So sun is dumping this energy onto the algae. Algae is utilizing photosynthesis, where it's like, okay, I'm gonna take carbon dioxide, I'm gonna reject the oxygen, I'm gonna take the water, I'm gonna reject the oxygen, then I'm gonna make sure the carbon and hydrogen, they get married together and make a nice baby, which we call hydrocarbons. And that's the foundation building block of everything organic. So hydrocarbon, and then you can burn that hydrocarbon in jet fuel if you want to. So that's the whole step number one. Basically, you take carbon, you dump energy into, basically take carbon dioxide, you dump energy into the system, add hydrogen if you want to, and you have a fuel. Now you may be like, that's a short-term solution, because at best case scenario you are creating a loop of carbon dioxide. Now that itself is a good thing, because we have to understand this. Like, we cannot keep adding more fossil fuel based carbon dioxide. We have to stop that. But some things cannot be changed into other green alternative. For example, there is no alternative to jet fuel, there is no alternative to rocket. But if you can use that as in like a looping system, where it's like, okay, it's just solar energy, it's just like long route of solar energy. It's like, yeah, algae absorb carbon dioxide from the atmosphere, dump back into the atmosphere while we are burning the energy. It's just solar energy with extra step, but it does work. So that's a short-term solution, but it does have advantage: profit. Now, profit is a very interesting aspect of it, because if it's profitable, people will research on it. The more people research on it, the more minds are poured into it, the more we'll figure out how to extract carbon dioxide from whatever sources we are working on efficiently. And that's a critical aspect. It's like, the more R&D we need, the more R&D we get, the more efficient tools we get, the more practical this system becomes. Right now, these things are what we call pilot project, prototype level. None of them is like, okay, buy here and done. None of it is there, because we do not have enough R&D, we do not have enough anything. So to solve that, we have to create a self-sustaining. To make it self-sustaining, it must create profit. Fuel is very profitable. Now that's step number one. But again, most people are not that keen into it, because while it does make profit, everybody knows it's just like, you're taking long route. It's not that beneficial. But what if we take another route, where we take carbon dioxide and we mineralize it? Basically take the carbon and be like, you shall bond to something else, or heck, the whole carbon dioxide bond with something else, and you behave like a stone. Basically, Earth has a very good carbon capture cycle, which involves everything. Basically, it can directly take carbon and squish it into hydrocarbon, like using photosynthesis, and then squish that puppy onto tectonic plates and then make it into coal. Basically, it has a good trapping ability, but it can do direct reaction also. Basically, stones can react with carbon dioxide over time and basically trap it into carbonates. So it's like, bro, you shall be permanently trapped here. And that's a very efficient system. You trap it and it's a stable system. If fire happens, it's not gonna magically react. It's basically, have you ever tried to burn a stone? So that's the whole point. If you can make carbon dioxide into mineral, carbon dioxide mineralization, you have a permanent solution where you are no longer releasing it. It's not a cycle. It's just like, stop, that carbon dioxide is no longer our problem. So making bricks, making cement, making concrete, these sort of things out of carbon dioxide, it's a very good long-term solution. Now that's again a long-term solution, not a final solution. To achieve that quote-unquote final solution, we have to bury it. Basically, we have have to go back to a square one. Fossil fuel was quite awesome. It taught humanity a lot of things. It made humans self-sustainable enough where we are like actually thinking about going to other planets. So it was awesome, but we have to be like, okay, that was a good tool. Now we need better tools, and we have to dump back the fossil fuel. Basically, all we have to create whatever energy source we can, and we basically undo everything we did so far and dump all this carbon dioxide back into the oil reservoir, back into basically, in some people are thinking about making into carbon dioxide into liquid carbon dioxide and dumping it into ocean floor. Now we're like, why the heck you want to do that? Because ocean floor is permanently under that kind of pressure. CO2 cannot go back to gaseous state, so it will not fundamentally mix. However, little bit of leaching will happen, but right now that leaching is happening from atmosphere itself. So the option is, if you can leach, like let's say 50 tons are leaching from atmosphere to seawater, and if you directly store 5,000 tons of basically liquid CO2 under sea floor, it's gonna barely leach like 5 tons. So it's like a lesser of two evils, but it's a long-term solution because there is no risk of it ever coming back, because fundamentally even an earthquake will not create a crack through water. That's not gonna happen. So fundamentally that's a very good kind of option. It's like put it and forget it kind of option, because the only way to be guaranteed that we can put carbon dioxide back into the land, well, we can't be guaranteed about it, because land never holded carbon dioxide, it always holded hydrocarbons. We know if we make it petrol again, basically let's say you are doing an algae bio plant and all you are doing is just like make algae, extract the algae oil and just dump it back into the ground. We know for a fact that will remain there. Why? Because it was there for millions of years, so we know that will stay there. But whenever we are trying to do with other things like carbon dioxide, we are randomly finding, hey, wait a minute, earth has a little bit of tremor and CO2 leaks up, or its CO2 ends up reacting with water supply or reacting with other bio life. Those things are not long-term stability. So that's why people are looking into ocean, because that's a lesser of evil. And fundamentally we have to make oil back again and be like, okay, just earth knows how to handle oil, so we are like, okay, mother earth, take care of this oil for us. So we have to do something with CO2. Now what we can expect in the future. Now this is one thing that prompted me to make this video so late, is simply because a lot of work needed to be done at this point in time. The only green technology that is like ready, go, like you may have already experienced this, is solar, because solar has reached that economical point where it's like it's beneficial to do it. Wind almost reaching there, and more than enough people have seen it. It's like, dude, I earlier did not realize why the heck so many people wanted to make wind farm in sea. I realized it's very easy for transportation. Think of it this way, like you are making giant objects, transporting that giant object through roads and all that, it's very expensive. What if you can make your factory directly on shore and you plant the damn thing directly on the sea itself? So everything is optimized for that. So even though it's a bit more expensive, power plant wise, but more expensive, it's much more efficient. So basically once you do 1, 2, 3, then you're like, okay, I can do 500 very easily. So same way we have to do a lot more work on this front, where we can actually like, okay, we can extract the carbon dioxide, either make it into fuel, make it into something permanent, or send it back down. We have to figure a lot more things out. Right now it's nowhere near efficient enough. We don't have anything. Heck, there are some plants that actually had that carbon capture directly from fuel, where they are like, okay, we are getting natural gas, we're gonna extract carbon directly out of it using some methods, and we only gonna burn hydrogen, so we only have water vapor as exhaust, and that energy surplus, not surplus, as it was like a little bit of energy we'll spend on that carbon dioxide and send it back down. Did it work? Yes. Then why did those projects stop? Simply because the electricity cost, per unit cost, started to go up, and then people are like, dude, I won't pay for this. Like, that's why I specified economics is the key here. It's like, does it make sense to do it? Then it will become self-sustaining, like solar. If it does not make economical sense, you can keep begging governments for like subsidies and all that. It's just not gonna work. So that's why jet fuel option is the most interesting one, because there is, if enough profit is there, then people figure things out, and once people figure things out, enough minds goes into the, enough competition is there, we never know what we will end up finding in the future. So lot of work needs to be done. And another aspect, this is not a final solution. Even if in tomorrow we figure out some magical way of like okay, we got this, we can do this carbon capture thing reliably, we have to stop doing it. It's like a it's not a system. It's not like staying in a hospital permanently. We have to stop doing that. So it's a short-term solution where it's like, okay, you are bleeding, we're gonna do this, we're gonna take care of you, we're gonna dilute your blood with whatever IV or something like that, and then we're gonna let your body recover. So it's like that. It's not a final solution. It's not one thing that's gonna take care of us. It's not that. Renewables are this, not, but it will become important because we are dying right now. So time is of the essence. So, and we have to take care of it. Like a CO2 basically level went from 200 parts per million, which is generally considered to be GG spread, to 300 to 400, and by the time we humans actually have grasp on it, it will take around 600 to 700 at that point in time. But we are applying, like that would be the step where we'll apply brake, but brake will not do anything. We have to apply reverse gear. That's why carbon capture is a necessary evil. We have to do this. It's not optional. Even if it triggers some false security where people are like, dude, we can just carbon capture, so you keep using fossil fuel. It's not gonna do that. So that's the whole point. It is important. We cannot neglect it, and we have to realize this is a tool that we have to apply in short term, as in like thousands of years. Like this will be like we did this for 100 years and then we have taken care of the situation, and then this will be one of the many tools, because final solution would be, let's say we made a concrete system which is like, hey, this new concrete is far more efficient to make, and it also takes a carbon dioxide. Like nobody would care about the carbon part. They will like, dude, this concrete is cheaper, it's better, everybody is making that. Like we will not even notice it. Like every concrete industry would be like, yeah, that's all we are doing. Then we may find out like, 500 years from now, dude, carbon dioxide levels are new low, because like, all the concrete started to absorbing it slowly, and if we are not adding more, we may randomly end up in a state that was like, whoa, release carbon dioxide in the atmosphere. So that would be the awesome part of it. But right now these things are far ahead. Like a lot of research, a lot of development has to be done, and we have to understand our mindset, where it's like we have this really short-sighted where it's like, dude, give me one tool to solve it all. No, we messed it up with hundreds of tools. We have to use hundreds of tools to solve it. So this was my presentation on basically carbon capture and storage technology. Hopefully this would have given you some idea what the heck people are talking about whenever they are talking about it. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.